Hello everyone, my name is Sumedha and today we'll study about collisions. Now from the definition of collision, a collision is said to be occur either if the particles or objects collide with each other, or we can say if the path of one particle or object is affected by the force exerted by another particle or object. For example, कोई एक पार्टिकल है and there is another particle, say m1 of mass m2, they are moving with different velocities and they collide, then this is called collision. We have two types of collision. One is elastic collision and other is inelastic collision. Under elastic collision, my total momentum of the system is conserved. Under inelastic, total momentum is conserved. Total energy of the system is conserved. Similarly, under inelastic, total energy is conserved. Under elastic collision, kinetic energy is conserved. Kinetic energy of the system is conserved, but under inelastic collision, kinetic energy is not conserved. So we'll study both the collisions, elastic collision and inelastic collision one by one. Now let's study elastic collision in one dimension. For that, consider I have two particles. One is of mass m1 and other is of mass m2. So particle 1 is moving with the initial velocity of u1 and m2 is moving with initial velocity u2. Particle m1 and m2 collides, then they move separately after collision with velocity v1 and velocity v2. So, as we know, momentum is conserved. So, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. We'll do rearranging. m1 u1 minus m1 v1 is equals to m2 v2 minus m2 u2. m1 is common. u1 minus v1 is equals to m2 v2 minus u2. So this is equation 1. We also know kinetic energy is conserved as this is elastic collision. So half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. So I'll get m1 u1 square plus m2 u2 square m1 v1 square plus m2 v2 square. Again rearranging, m1 u1 square minus m1 v1 square is equals to m2 v2 square minus m2 u2 square. m1 common, u1 square minus v1 square is equals to m2 common, v2 square minus u2 square. So this is equation 2. Now dividing equation 2 by equation 1. Equation 2 divided by 1. We'll get m1 u1 square minus v1 is equals to m2 v2 square minus u2 square divided by equation 1, m1 u1 minus v1 is equals to m2 v2 minus u2. m1 cancels, m2 cancels. Now we see this is u1 square minus v1 square. We can use an identity a square minus b square is equals to a plus b, a minus b. So using this identity here, we'll get u1 minus v1, u1 plus v1 upon u1 minus v1 is equals to v2 minus u2, v2 plus u2 upon v2 minus u2. So here this will get cancels out and I am left with u1 plus v1 is equals to v2 plus u2. Or I can write this u1 minus u2 is equals to v2 minus v1. So we get u1 minus u2 is equals to v2 minus v1. u1 minus u2 is equals to v2 minus v1. So what does this result says? u1 minus u2 is the relative velocity of approach, is relative velocity of approach, and v2 minus v1 is relative velocity of separation after collision. That means u1 and u2 before collision are approaching with which have relative velocity u1 minus u2, which is equal to the relative velocity of separation after collision. So this was about elastic collision. Now from the previous derivation we have come to this result. Using this result we'll find final velocity of object. Again using conservation of momentum, I'll get m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, or m1 u1 minus v1 is equals to m2 v2 minus u2. So this was also our equation 1 in the previous derivation. Now from here I'll get the value of v2, u1 minus u2 plus v1 is equals to v2. Substituting this value of v2 into this equation. Before substituting, let us solve this little more. m1 u1 minus m1 v1 is equals to m2 v2 minus m2 u2. Here is v2. Substituting the value from there, I'll get m1 u1 minus m1 v1 is equals to m2 v2 is u1 minus u2 plus v1 minus m2 u2. Solving this further, m1 u1 minus m1 v1 is equals to m2 u1 minus m2 u2 plus m2 v1 minus m2 u2. Now I'll see अगर कुछ कैंसिल हो रहा है तो I'll cancel from this equation. m2 u2 minus this is also minus, तो कुछ भी कैंसिल नहीं हो रहा है. So I'll write this equation as it is. m1 u1 minus m1 v1 is equals to m2 u1 plus m2 v1. This is minus m2 u2 minus m2 u2 minus twice of m2 u2. m1 u1 minus m1 v1 is equals to, taking m2 common, u1 plus v1 minus 2 m2 u2. So now we have to find the final velocity of object, which is v1, because we have substituted v2 in terms of u1, u2 and v1. So v1 की सारी terms एक तरफ and बाकी terms एक तरफ. So I'll get m1 minus m1 v1 from here minus m2 v1 is equals to m2 u1, this will get there, minus m1 u1 minus 2 m2 u2, or I'll get minus v1 common, m1 plus m2, which is equals to m2 u1 minus m1 u1 minus 2 m2 u2, or I can write this as v1 m1 plus m2 m1 u1 minus m2 u1 plus 2 m2 u2. I have just multiplied the whole equation by negative sign. So from here I'll get v1 is equals to m1 minus m2 u2 u1 common plus 2 m2 u2 upon m1 plus m2. So this is the final velocity after collision the object m1 moves with. Similarly, if we replace or if we get v1, v1 is equals to v2 minus u1 plus u2, and substitute v1 in this equation, I'll get the value of v2, which is equals to, I'll get the value of v2 is equals to u2 m2 minus m1 plus 2 m1 u1 upon m1 plus m2. So these are the final velocities of object. Now, case 1. If the mass of two bodies are same, that is m1 is equals to m2 is equals to say m. So what will be the final velocities? v1 is equals to, mass same hai, m1 is equals to m2, so this will get 0. I'll get 2 m u2 upon 2m. This will give me v1 is equals to u2. That means final velocity of object m1 is equals to initial velocity of object u of object M2. Case 2. If one object is stationary, say my object 2, that is M2, is stationary, then initial velocity of the stationary object will be 0. U2 will be 0. So what will be the final velocity? V1 is equals to U2 is 0. I'll get M1 minus M2 U1 upon M1 plus M2. Similarly, I'll get V2 is equals to U2 is 0. So I'll get 2M1 U1 upon M1 plus M2. So these were the two different cases for elastic collision. Now let's discuss elastic collision in two dimensions. In two dimensions, what will happen? Mass M1 is moving with U1, mass M2 is moving with U2, and they collide at a point. Then M1 moves with V1 in this direction and M2 moves with V2 in this direction, and they make angle θ1 and θ2 with this axis. So now we have to make components of M1 and M2. So here I'll get M1 V1 cos θ1, M2 V2 cos θ2. Similarly, M2 V2 sin θ2 and M1 V1 sin θ1. So we get the components along x-axis and y-axis. Again, conservation of kinetic energy, half M1 U1 square plus half M2 U2 square is equals to half M1 V1 square plus half M2 V2 square, or M1 U1 square plus M2 U2 square is equals to M1 V1 square plus M2 V2 square, or we can write as M1 common U1 square minus V1 square, M2 common V2 square minus U2 square. Now applying conservation of momentum. Now in conservation of momentum, I'll do x-axis first. For x-axis, M1 U1 plus M2 U2 is equals to, x-axis पे क्या है? M1 U1 plus M2 U2, then M1 V1 cos θ1 and M2 V2 cos θ2. M1 V1 cos θ1 plus M2 V2 cos θ2. This was for x-axis, and for y-axis, पे initially there is nothing. Y-axis पे initially there was nothing, so it will be 0 is equals to M1 V1 sin θ1 minus M2 V2 sin θ2. Negative sign is there because there is opposite direction of both. So here I'll get M1 V1 sin θ1 is equals to M2 V2 sin θ2. 2. So again, using these two equations, we can calculate the final velocity as we did in one dimension. Now after discussing elastic collision, let's discuss inelastic collision, a perfectly inelastic collision. In this, what happens? Say I have a mass 1 moving with velocity u1, mass 2 moving with velocity u2. They'll collide and moves with same velocity. This is my inelastic collision. For this, let's apply conservation of momentum, because momentum is conserved in inelastic collision. So I'll get m1 u1 plus m2 u2 is equals to m1 v plus m2 v. m1 u1 plus m2 u2 is equals to m1 plus m2 into v. m1 u1 plus m2 u2 upon m1 plus m2 is equals to v. In inelastic collision, kinetic energy is not conserved. That means there is loss in kinetic energy. Kinetic energy is not conserved under inelastic collision. So there is loss in kinetic energy. So we have to find that loss in kinetic energy. So what will be the loss of kinetic energy? Kinetic energy initial minus kinetic energy final. So kinetic energy initial is equals to half m1 u1 square plus half m2 u2 square, and kinetic energy final is equals to half m1 v square plus half m2 v square, or we can write half v square m1 plus m2. So the loss in kinetic energy is equals to initial half m1 u1 square plus half m2 u2 square minus final half m minus half v square m1 plus m2. So I'll get, now substituting the value of v square or v from here, so this is equation 1. From equation 1 we'll substitute the value of v. So I'll get half m1 u1 square plus half m2 u2 square minus half, what is v? m1 u1 plus m2 u2, m1 u1 plus m2 u2 upon m1 plus m2 whole square into m1 plus m2. So now we'll solve it. Half m1 u1 square plus half m2 u2 square minus half m1 u1 plus m2 u2 square upon m1 plus m2 square into m1 plus m2. So 1 will get cancelled. So we'll get m1 u1 square upon 2 plus m2 u2 square upon 2 minus a plus b ka whole square. We'll use that identity here. We'll use a plus b whole square. So we'll get m1 u1 square plus m2 u2 square plus 2 m1 m2 u1 u2 upon 2 m1 plus m2. Now we'll take a LCM. We'll take a LCM 2 m1 plus m2. So we'll get m1 u1 square into m1 plus m2 plus m2 u2 square into m1 plus m2 minus m1 square u1 square minus m2 square u2 square minus 2m1 m2 u1 u2. This minus is multiplying with whole this bracket. Therefore, जैसे ही ये bracket open होगी, this minus will get multiplied to each term. Therefore, minus minus minus. So we'll solve further. m1 square u1 square plus m1 m2 u1 square plus m2 square u2 square plus m2 m1 u2 square minus m1 square u1 square minus m2 square u2 square minus 2 m1 m2 u1 u2 upon LCM 2 m1 plus m2. So जो terms cancel हो रही है will cancel out. m1 square u1 square minus m1 square u1 square, m2 square u2 square minus m2 square u2 square. So this cancels out. We are left with m1 m2 u1 square plus m1 m2 u2 square minus 2 m1 m2 u1 u2. So ये आइडेंटिटी बन रही है. That is m1 m2 u1 square plus m1 m2 u2 square minus 2 m1 m2 u1 u2 upon twice of m1 plus m2. ये रिजल्ट आया हमारे पास. अब हम इसको फर्दर सॉल्व करेंगे. दिस इज टेकिंग अ फॉर्म ऑफ आइडेंटिटी. यू विल सी if I'll consider this a, so a square plus b square minus 2ab. So we get this. Now taking common, we'll get m1 m2 common, u1 square plus u2 square minus 2 u1 u2 upon 2 m1 plus m2. This is taking a form of identity. So we get loss in kinetic energy is equals to m1 m2 u1 minus u2 square upon 2 m1 plus m2. So this is my final loss in kinetic energy for inelastic collision. So after studying about elastic and inelastic collision, we'll discuss coefficient of restitution, which is denoted by small e. It is the ratio of magnitude of relative velocity of separation after collision to the relative velocity of approach before collision. That is v2 minus v1 upon u1 minus u2. मोड है दोनों का, so we can write v1 minus v2 upon u1 minus u2. So now what is the significance of this coefficient of restitution? This is that it is used to distinguish between different type of collisions. For example, if there is an elastic collision, coefficient of restitution will be 1, that is E equals to 1. For superelastic collision, E will be greater than 1. For inelastic, E will lie between 0 or 1, but that will be less than 1. and for perfectly inelastic collision, E will be 0. So this was all about collisions, elastic collision, inelastic collision and coefficient of restitution. We'll see you in the next video. Till then, keep revising.